So welcome, good morning. Another one of my C++ talks. This year I wanted to be more on the easy side with some simple stuff, but I'll do it interactively. So now is the time to silently leave if you don't want to get into interaction early in the morning. Subtle C++, very tiny bits. Let's start with the tiniest of tiny operations that we have available, unary plus. So what is this good for? Why did they even invent it into, I mean, it comes from C at least, and probably before. What's the point of even having that? Plus 3 is the same as 3. What's the plus minus 0? Does anybody know? Minus 0, still. So that's mathematics for C++ programmers. Because the definition of unary plus is just to take the argument and return it unmodified. But there's one point in having that and using that, because it's not only returning it, but before it returns it, there's integral promotion. So when you put in something that is not int or smaller than int or in enum, then it gets promoted to an int. So the typical or the canonical use case is you want to print out some error value that is in an enum. And enum values can't be streamed into cout or into our cell debug, which uses cout underneath. So what you use there is the plus to force the compiler to not have the enum value there, but an integer value, which then can be printed. Sadly for enum classes, that no longer works because they cannot be converted implicitly to an integer. You need to explicitly static cast them. Or so this has become that common a thing that in C++ 23 they invented this to underlying thing, so that you can convert the enum class value into the underlying type, and we have that as 032TL in our libraries because we are not yet 23, but still stuck with C++ 20. The good thing with C++ 26 will be that we don't need this anymore at all. So Tor is no longer in the audience. He's doing train rides these days, but he always complained that if I have such an enum, what this prints out is just a value. And I have a long list of enum values, 200 maybe, in one place. And which one is number 57? So you have to count through them in the code to find out, this is a error code 57, which is something. You want to have the actual value, the actual string, the identifier printed there. That's not possible with C++. Because it's all evaporates at compile time into just bits and values. But C++ 26 will most probably have reflection, and with reflection there'll come the possibility to at compile time add functionality that takes an enum and generates a function that prints the identifiers as strings for all the enum values. So in a couple of years, we'll be able to read actual enum identifiers instead of just the digits. Another use case for exactly this is not only enums, but also if you have in our code base this cell int8 stuff and you want to print it out, what usually happens if you print it out with a standard count or the cell debug is that you see nothing. There's no value printed at all. So you have a variable of type cell int8, and you want to see the value, and usually there's a small value in it, or like a 0 or a 1 or a 3, and it prints nothing. Why is that? Yeah, cell int8 is actually a type def for signed character. And printing a signed character, actually the compiler will then print the character itself, and that's a control character, so there's nothing to print, there's nothing showing up on the screen then. But if you plus that one, then it'll print it as well. So that's the one and only use of good use for the unary plus. There's one more use for it. So what it does is it does integral promotion, and it also operates on pointers. So what's the upper decal type of this short lambda function? And what's the lower one? Any ideas? No, it's all your morning still. Well, the upper one is just the decal type of this lambda thing, and the lambda underneath is just a class that pretends to be a function, but it's actually a class type. So this will be some compiler made up class type. The lower one, we want to use operator plus on that. A lambda is a class, it's not a function, but plus can only operate on integers and on functions. Is there a way to go from a lambda to a function? Yes, there is. For these kinds of lambdas that don't have any captures, they have an implicit conversion to the function type. So in the lower case, we are forced to come up with a function type. We do have a function type for this. This is a lambda that takes nothing and returns nothing and does nothing. It's a zero lambda. And so this is one use where you can, another use for the unary plus, which is rarely used. I mean, this would be useful in a case where you have a template, a parameter, unconstrained, and you want to make sure if you pass in a lambda there that it only decays to a function. So you then store that in some place, and you don't want to store this big lambda thing, this class object, but you just need the pointer in the end. So you want to make sure that your template function that takes this stuff in as a template, and then in the upper case will decide to have a big class stored somewhere. It just needs to store the pointer actually, so you can use the lower case to get that. If there's any, yes, questions?
Would this work in case the capture list is not empty?
No. So the question was, would that work if the capture list is not empty? When the capture list is not empty, there is not this implicit conversion function generated by the compiler in the lambda class, because yeah, we need this pointer for the class in the pointer case, because we have to store the captured variables somewhere and carry them along. Good question. If there's any other questions, then just shout. Going from unary plus to unary ampersand. What gets printed here? Any ideas? How hard can it be? Extremely hard. I have no idea what gets printed there. What gets printed in this case? No, we still don't have an idea what gets printed, but we now have a clue. I mean, we assign 3 to x. We then call a function on x. We'll do something. We'll write hello world to standard out or something, but it doesn't return anything. And then we print x, so must be 3, right? No, in both of these cases, the function, of course, can modify the x. Even in the previous one. Don't know how to go back there. Let's go forward. So in both cases, the variable gets modified, but in the second case, the reader at least has some clue. There's an ampersand in front of the x, which gives the reader a clue that this might be a function that takes it as an in-out parameter, so does modify this. So one useful convention is to, if you have out parameters, to always pass them by pointer, so that the reader, so that you have to add an address to it when you call it, so that the reader has at least some subtle clue that it might be something that modifies the variable. Otherwise, in the upper case with the by reference thing, you have 0 clue and then wonder why your variable gets modified behind your back. Carrying on with reference types. So there is some misconception that if you have a pointer value and that pointer value can never be 0, then it might be useful to replace that with a reference type, for example, for a parameter. Is this the same thing? So is a reference just a pointer without a null pointer? Something completely different. So what's the size of a car pointer? And what's the size of a car reference? Are they the same? They should be if one is just the other without a null pointer. Not at all. So the first one is a pointer, and 64-bit machines usually have a pointer size of 8 bytes or whatever the size there. But the size of a car reference, of course, is you're just referencing that car. That's just another name for that value somewhere. So this is not a pointer at all. This is just, I have a different name for this memory cell. And how that is represented is completely the compiler's secrets. So you don't have a pointer at hand there. You don't manipulate a pointer. It's just another name to reference that character. So beware. And carrying that analogy a bit further, not using reference as a replacement for non-zero pointers. If you have a function that takes a non-zero int, what would you use as a type for that? You would use int and then have an assert maybe in there or have some documentation. Never pass in 0 here because I don't want that. What's the type for a function that takes a non-null pointer to int? That's again, you don't have a type for that, a natural type for that in C++. You can't express that in the C++ type system, just as you can't express an integer value that cannot be null or 0. So you use the usual integer type and then have documentation or have an assert. Or you use this stuff that got invented. So when these, there's this initiative that has this C++ guideline thing for writing better and safer C++. And then I think it's a Microsoft sponsored initiative to have this library, the support library, guideline support library, I think is this GSL. We don't use it anywhere in the code, but I think it's a headers only thing though, if we wanted to use it. And that has some abstractions like this not null pointer thing so that you can be very explicit about your functions not passing or not wanting a null pointer there. But I guess, yeah, most of the time we just live with a documentation and assert or the occasional crash if you didn't read the documentation. Sorry? Yes?
For the second case, I like to use int reference, for example, to give a hint set. For the second case, I like to use something like int reference to make clear that I expect a value and not a null pointer. Isn't that valid? For a hint?
Yeah, but it's, again, what's so special about the null case for the pointers compared to the 0 case for the integers? Nothing. So from it doesn't hurt in that case, but then if you want to store that somewhere, if you want to operate on that value further or move that value further, then you get into the case where where you no longer have this pointer thing that you move, but you accidentally move the pointer to thing around. So can be dangerous. And from a philosophical standpoint, it doesn't make much sense. Which brings us back to 0 again. So what's the difference here in all these three declarations? Is there any? Not really. Technically not. They're all initializing that variable to 0. So what are the second and third ones good for what's their use. Again, subtle things. It's just a clue that you're initializing the variable just because the compiler is too dumb to find out that you're not using the value. So if there's complicated logic assigning to that x and then using that x in different if-else branches, then it might be obvious to the programmer that x will never be read before it has been written to, but it's too complicated for the compiler to find out, so the compiler will emit these maybe uninitialized warnings. So what do you do then to silence that warning, to get a warning-free build? Yeah, you do assign to that variable, but then why use 0? That then gives a clue to the reader that it is important that this variable has the value 0 at the outset, because some of the logic will depend on it, but none of the logic depends on it. So you're setting a red herring there to the reader that 0 might be it might be important that you initialize it to 0. So if you use these other more vague variants, what value to put there, then they just say, put some value there. I don't care because I will never read it. And that gives kind of a clue and a promise to the next maintainer of the code that it's irrelevant what value is there. It's just to silence the warning. So another case of being maybe a bit too subtle in the code. I don't know. So next thing, we're getting a bit more complicated here maybe, or a bit more exciting stuff. What's going on here? In the uppercase, we have an outer variable and then an inner block where we have a variable of the same name, which will, of course, generate a compiler warning, but just ignore it for the moment, that there will be a warning there. So what's the value that gets printed in that case? 3, maybe, who knows? In the lower case, we have a lambda with a capture, and that capture takes an x, and then captures that x and prints that x. So what does that print? Miklos. Yeah, that one prints a 3, is definitely, because, wait a second, and the upper one, you're still with a 3? Okay. Bam, you lose. The upper one is undefined behavior. World is ending. Because in the upper case, this x is a reference to that variable that we just declarate and introduce. So it doesn't have a value yet, so it assigns non-value to non-value, and then you want to use that value and print it, and that is undefined behavior. In the bottom case, for the captures, they thought, maybe it would be a good idea if this second x doesn't reference this x because it's useless, as we saw in the upper case, we don't have any use case for that. Maybe there might be a use case to have this x actually reference the outer x. And there is one use case for that. Because this second part of this equation can't only be a number or a value, simple value, but it can also be some function call. So if you have a very big value in the outside that you want to capture, a big moving van, and you're sure you only need that in this one place and not afterwards, you could move it so that the capture doesn't take a copy, but can actually move it in. And for that use case, the special casing of the right-hand side references has been added so that this particular case works. And in this particular case, it's also kind of useful to reuse the same name. And I'm not sure if the compilers, I guess they wouldn't warn in that case. I didn't check. They don't. That's good. So I'm telling you old news here. Sorry for that. So getting back to something more more fundamental, not even C++, but maybe relevant for other kinds of languages as well. We have commands. And idly is often, if there's a long list, for example, a long list of enum values, and there's a command in the middle talking about one of these values, does it talk about the value above the command or below the command? Sometimes you can guess from the context. Sometimes you're left clueless, then you do a git log to find out where the command was added, when the command was added to pertain to which of the two cases. If you start your commands with an uppercase, this, and then follow it with a colon, your way of reading that naturally makes you look at the next line. So this upper command is definitely for the text that follows, because it's introducing with an uppercase and leading on with a colon. In the second case, where you start small with a lowercase and just continue on from what you said before, this lowercase is just a command pertaining to the preceding stuff. So that's, again, maybe a too subtle clue, or I think from reading habits, it's not too subtle, but it's just the right kind of subtleness to make your mind just comprehend that what is the case or where it pertains to. So I think this is very useful. Unfortunately, our misguided use of Clang format, of course, has no idea what a command pertains to. So if you Clang format the code, then it might easily break the second case and move the command down behind it to make it look like it commands on the preceding stuff. So don't use Clang format. The good thing is if you have a spaceship operator in your code, then our version of Clang format can't use that anyway, so you have to move it to the exclude list, your file then. So do use the spaceship operator to get rid of Clang format. Pro tip. The other thing is about when you reference URLs in your commands. There's always the question, where does the URL end? Because a full stop can be part of a URL. So there's this tried and good old tradition of encapsulating URLs in some of the characters that have specifically left out of the specification for URLs that can't be part of a URL, which is canonically the angle brackets. You can also use quotes, but you don't want to talk in quotes usually about your URLs. And it's also a good thing to always, because URLs are ephemeral on the web, they come and go, and in 3 years' time, the URL that you found will no longer work. But if you also have some title for this and also mention that, then it will be easier for the next person to find that resource if it moved somewhere else, or even gives the reader a clue that they don't need to look at the URL now to get an idea what you're talking about, because the title already gives it away. Just a naked URL, especially if we have bug IDs, for example, then the bug ID doesn't tell you anything, but the title or the commit hashes as well for the git logs. Then the commit hash doesn't tell you anything about what commit this other person is talking about, but the title often gives you enough of a clue that you don't actually need to look it up yourself, but have an idea what this is about. And finally, if you have been to last year's talk, where I still have my red hat on, I talked about some exciting things with our string classes and with these non-type template parameters. And I was a bit wondering, so what you can pass into a template is not only types, but also values. But these values have to be of a specific kind, so you can't use any class type as a value. They need to be so-called structural types. And one point for structural types is that they must only have public members. And I was a bit puzzled when I first read that, why they need to be public. And I shrugged and said, so what, and made our class that we want to use there, made all the members public dutifully just to be able to use them, but I had no clue why, until I read a blog post the other day that nicely explains it. Because the issue here is, when you have two instantiations of the same template with the same class value, then these two should just collapse to one and the same instantiation. So you don't want to have different ones for these seemingly identical objects. So the compiler has to decide, I have two values of type standard string, and they must have are they identical in a sense? Well, what does a standard string do internally? It saves a pointer to the character string that you give it. And these pointers might be different in different compilation units, or even in the same compilation unit, they might point to different empty strings. And so if the logic to find out if these two values are identical, what does the logic do there? It compares the members of this class. So it compares the two pointers and the two sizes. And the sizes are the same. So string is typically implemented as a pointer in the size. It compares the pointers, they are different. And compares the sizes, they are the same, but the pointers are different. So these two would be different instantiations of the template. And that's, of course, not what the user wants, what the user expects. So for a string, the equivalence of these two values is not decided by the pointers, which is an implementation detail, but by the logical content, by the characters actually. And the private there gives the subtle clue to the compiler that this is implementation detail. So this is not what the compiler should use to decide if these two values are equivalent, because I hide that from the user. The user doesn't know that this is implemented with pointers. So this is not something that makes up the equivalence classes over this class. And that's why they demand that for types that can be used as non-type template parameters, that you always use only public members, because these public members are kind of, this is the face value of the value that's in there. And if there's a pointer in there, and if there's two instances with different pointers, then you have to accept that they are non-equivalent, because you have access to these pointers. They are not just an implementation detail. So that was why we had to make these members public a year ago. And with that, and I think we're well in time for maybe one last question. And if you are fed up with C++, do it like me. Just take a break in the lake. Any questions left?
I guess it's not on the list of subtle C++ things, but it's just coming up a lot in the Converti list is double locking, which we've struggled with in the past. And now with standard atomics, they have this claim that there is the standard locking pattern is available. On the other hand, then there's the argument that maybe standard mutex is so fast that double locking is wasting everybody's time. So where would you stand on that?
I wasn't even aware that we would be guaranteed now with, yeah, it should be, yeah. But yeah, as you say, so the question is double locking worth it? 10 to 15 years maybe ago, there was a big thing about this double logging. So you first check a value, and then you take the log, and then you recheck the value, and that was touted as something that is faster than taking a log, and then only then using the value. But then people found out that with the compiler architectures and the guarantees that the compiler gives, not the compiler architectures, but the machine architectures versus the compiler guarantees, that this was completely undefined and could you do anything if you used anything but an Intel machine where it just happened to work. And then that case settled, like everybody started to use mutexes to even be able to wrap their head around their code. I think it's much better and much cleaner to have a mutex that tells you in the code what variables am I using this mutex over, and don't try to do subtle tricks that might give you a. I mean, if you have a inner loop that could benefit from it, and you can demonstrate that it benefits from it, maybe then it might be useful. But I guess most of the time these days it's much more important that the data is structured in a way that you don't need to access too many pages and don't have cache misses and stuff like that, than worrying about these mutexes and trying to be too clever there and too subtle there for no added value. So these subtleties all try to give some value at least and explain why they are there, but they're not counterproductive, non-value subtleties. They are bad. What is double locking? Yeah, that's try to explain it in a very short term. Otherwise, just look it up. It's this idea: if locking a mutex is expensive, and you want to initialize something, it might already have been initialized. So you have a very expensive function that initializes a variable, and the variable starts out as 0 or null, and then you want to, if on first use, you want to put something in there. You call it an expensive function that computes a value that you then put into that function. And if two threads at the same time call into this to use the value the first time, then each of them would see the value is still null. I need to call this expensive function and then store the value into the variable. And both of them would call this expensive function, and that would be wasteful because only one of them would need to do so. So the idea was that you first look at the value. No, I'm now talking nonsense because in the end they would both call it. But the issue was with overriding. So it starts to be a bit complicated. Yes. Sorry?
I don't know much about those topics. So.
Okay, then do read up on that. Do look at the double-check locking pattern. It's a term of art. I'm just too dumb at the moment to explain it in 3 sentences. Sorry for that. But read up on that. That's interesting because, as I said, it was thought to be the big thing, and then everybody discovered, oh, it doesn't even work. Which is kind of nice because you have this idea of knowing how these abstractions work, and then when you start to peek under the cover, that these abstractions are not perfect, and you see underneath, and what happens underneath is actually counter to what you assume about how your abstractions on the upper layers in your stack of technology work, which is always an enlightening thing. I think we're well over time already. Sorry for that.
It's coffee break now anyway.
Oh, okay, even better.
Now a break until Armin is on at 11. Yep. So.
Yeah, because we are on coffee break, I have one more small question.
Yeah, why not? Or
You want the question in the recording? For the benefit of everybody.
So I was just wondering with the part where you initialize. What?
this is off.
It's done? No. I was just wondering on the part where you initialize with 0 or not with anything, what I would use is a variable and directly in brackets the 0, so the constructor of int. Would that be okay?
In curly parentheses.
No, in normal brackets, the constructor of int. Int a
Yeah, that's
0.
okay. Yeah, that also works, but again, you have the 0 there and give the impression that 0 might be something of value, but it is not. So the point there is to not give any actual integer value there, but just give something, some fluffy syntax that says this is some value, but it happens to be 0, but I don't care about it being 0.
Does int have an empty constructor? Just the brackets?
Yes, that also works. That also is 0.